Class, today's video is going to be over section 1.5, solving linear inequalities. So this is of we've had some fairly heavy algebra in this unit between the review section, um, and like the 1.1, we got into really messy equations at some point. The nice thing I'd like as an instructor about solving inequalities is if you can solve linear equations, you can solve linear inequalities. It's the same exact skill set. There is like one extra little step you have to watch out for with inequalities. And when we do compound inequalities, like knowing like what you're solving for is important. It's a little bit different than the inequalities, but the solving process works the same. Um, the to me though, the important part of why we're covering section 1.5 is not about the solving, it's about how we deal with the answer. And so I think a lot of times as students, since you spend most of your time with the solving process, you kind of focus on that. But it's really the answer part that's important because not so much the graphing of the number line, because we're talking about inequalities, let me back up, sorry. We're dealing with greater than and less thans. And so now we're not having like x equals a number, we're having x greater than or less than a number. And so because of that, we're going to have like an infinite number of solutions. And so we need to be able to, one, graph them on a number line, and two, write interval notation. And for me, the important part of this for the rest of the semester is the interval notation, because when we do domain and range is all about interval notation. There are many times in both Unit 2, Unit 3, that interval notation gets used. And so if you haven't seen it in a while or seen it at all, this is our introduction to interval notation. So to me, that's the important part of this. As always, I'm taking notes from the lecture notes from Blackboard. Let me, and if you see this semester, this is the last topic that we're covering. Some semesters also have time for absolute value equations. This semester, yeah, I'm here on a Saturday making this in my office because this is that week that school is closed down the whole time. So I'm just used to the spring semester. This is the third year in a row that I've worked here at Carl Albert that I've lost a week of on-campus time due to bad weather. So I was kind of planning ahead, knowing we're going to have as much time as I'd like. So that's why we're stopping with this instead of doing 1.6 as well. So this is, for this semester, this is the last topic for test one. So we're going to spend, again, we're going to talk about the solving. I will say on the solving, like hopefully you've done your 1.1 homework, and there were some messy equations in section 1.1. The equations, the inequalities we're going to deal with in 1.5 are much more basic compared to most of what we did in 1.1, because we're not worrying about so much about the solving part. We're worried about how to answer the question part. So we're going to talk about the inequality notation, how to graph it on a number line, which in MyMathLab, that's going to be multiple choice. So I'm definitely going to bring up MyMathLab and walk you through that. And then we need to start talking about interval notation because that's something that takes some practice, particularly if you haven't seen it before or seen it in a while. All right, so those are our goals for today. Let's jump into the problems. So before we get into the solving, let's talk about the graphing. All right, so when we're dealing with when we're dealing on the number line with the graphing, if you have greater than or less than, we're going to use open circles. Okay. Now, open circles, when we get to interval notation, open circles, we use parentheses. Because interval notation, basically interval notation is, how far left do we go? How far right do we go? So it's just the endpoints. And we'll talk about this on the graph as well. But so if it's strictly greater than or less than with no equals, we're going to be using open circles and parentheses. Now, if we have less than or equal to or greater than or equal to, the equal part, now we're going to use closed circles on the number line. Does that closed circle mean we can equal that number, or we're going to use brackets in our interval notation, except for infinities, and we'll talk about that. But when you see brackets, that means you can equal the number. So, that's one thing you have to keep straight, especially I've done this in a while. A lot of people sort of remember this once we start talking about it, but that's why we review it. So open circles, parentheses for no equals, closed circles, brackets, if there is an equals, other than infinities. So keep that in the back of your mind. The other thing you have to watch out for is like the direction of your graphing. So before we get into the solving, let's practice some of our graphing skills right quick. So write the inequality using interval notation, illustrate the inequality using the real number. When it says illustrate, that means draw it. So anytime you're doing interval notation, I always like to have the graph first because we're used to graphing these solutions on a number line. We're not used to interval notation. So if you have the graph, the interval notation comes directly from that. So how do we graph x is greater than or equal to 2? I always like to put 0 on there as a placeholder. And so there's our 2. So first of all, what are we going to put on 2? Open circle or closed circle? There's equals. So we're going to put a closed circle. Now, do we go to the left or to the right? And this is where, if it's sort of fuzzy, a lot of little mistakes are made because you sort of remember sometimes. The key here is if x is greater than, where do I put this? So if x is greater than, that means go to the right. Because if you're, the way we define greater than or less than on two numbers, whichever number is to the right is the one that's greater than. Now, when we read this, you generally read it from left to right. So you would read, the correct way to read this would be x is greater or equal to 2. And so if x is on the left side, the way you read it kind of lends itself to the graph. If x is on the right, you have to be careful because, if I wrote, because you can flip these things and it means the same thing. So you would read this as 2 is less than or equal to x, right? And so if you see less than, some people would think to the left because less than means to the left. But we're not graphing it based on 2, we're graphing it based on x. So if x is on the right, you still need to read this from x's perspective. So x, I don't know what you were taught. I was taught the alligator eats the bigger number, or the arrow points to the smaller one. So x is greater than 2. I would read both of those as x is greater than 2 because we need to read it from x's perspective. Right, so since x is greater than, we're going to the right. Now, how far to the right do we go? We're going forever. So that would be positive infinity. And positive, you don't, and the answer is we don't put positive on infinities. If we don't put a sign, we assume it's a positive. But you have to be careful because how far do we go to the left? And, if we were going forever to the left. Well, that's not infinity, it's negative infinity. So if you're just telling me infinity, you're telling me positive infinity. So you got to make sure that when you say negative infinity, you put the negative with it. If you don't put a negative or a sign with it, we're assuming it's positive. Something else, when in doubt, you can always try plugging numbers in and testing them. So so if x is 1, is 1 greater than or equal to 2? Well, no, that means you don't go this direction. But if you set that 3, is 3 greater than or equal to 2? Well, yes. And then you go to the right. So when in doubt, plug in numbers on either side and see which one makes sense to you. All right, so this is a standard inequality, just a single inequality. So we're always going to be less than or greater than. So we're always going to be either going to positive infinity or negative infinity. and then you have a starting number that's going to be open circle, closed circle, depending on whether or not there's an equals. So this is like the answer to solving a linear inequality. So what about the interval notation? Okay. Running out of room here. So the thing to remember for interval notation, and I've got it back up here on number one. So for interval notation, the general idea is how far left do we go, comma, how far right do we go? And then we're going to do parentheses or brackets depending on what's appropriate to the problem. So just remember, interval notation is just the endpoints. So. And the reason I said that I'd like to have the graph is how far left does this graph go? Well, the leftmost point of this graph is 2. Okay, now, are we going to put a bracket or parentheses on the 2? That's why we went over here. So if you have an equals, you're using a brackets with your numbers. Closed circle, bracket. So we do a bracket on the 2, because that's how far left we go, and then comma, how far right do we go? So how far right do we go? We go forever to the right, so it'd be positive infinity. Now, here's the thing: do not use brackets with parentheses with. Don't use brackets with positive or negative infinity. Always use parentheses with infinities. Doesn't matter what the number has, bracket or parentheses. Always use parentheses for plus or minus infinity. If you don't, you're going to get counted wrong. MyMathLab is going to count it wrong. I'm going to count it wrong. That's one of the places. That's one of the things we're picky about. And the reason you can't use brackets with infinity is because bracket indicates we can equal that number. So we can equal 2. We cannot equal infinity because we can never get there. So once, and again, even if the problem doesn't ask for the graph on the number line, particularly if you're new to interval notation, graph it, then you can see what's on the left, you can see what's on the right. That's your interval notation. Let me do number 3. Let me just start this on the paper. So number 3, we have -5 is less than or equal to x. It's less than 5. So we need to graph this on the number line, and then we're going to do interval notation. Like I said, I always like to put 0 as a placeholder. And we have 5 on one side, -5 on the other. So what does this mean? And this is what we call a compound inequality, because there are 2 inequalities. We could theoretically do and or inequalities. We're not going to, this is basically an and inequality. We're not going to get that messy. We're just doing the basics. Excuse me. This is one place I like the English, because some people read this as -5 is less than x, and then they just read it as, as -5 is less than x, it's less than 5. But what does that mean? I like the word between. This is one place where I think the English can really help us. So what that's telling us is x is between -5 and 5. And it also equals -5 because there's an equal here. So how do we graph this on the number? Well, we're going to start at -5. What do we put on -5? Open circle or parentheses? There's an equals. Sorry, open circle or closed circle. There's an equals on the -5, so we put in closed circle. There's no equals on the 5. We put an open circle. So those are the endpoints of the x's. And then what is x? X is everything in between. And again, in MyMathLab, this is going to be multiple choice, so you don't have to worry about the tools, figuring out the tools and how to graph this. So that is the graph. Now, what about the interval notation? Remember, interval notation is how far left do we go, how far right. So once you have the picture, how far left do we go? We go to -5. So -5 is our first number. Do we put parentheses or brackets? Well, with the equals, we use the closed circle. We'll also use the bracket on -5, and then comma. 5 is the right most this graph goes. And then since there's no equals, we used open circle there and parentheses there. So if you have a compound inequality, x is going to be between two numbers. So we're not going to have positive or negative 50 on the ends. We're going to have two numbers on the ends because x is going to be between those two. And then number 4, we have -7. I probably shouldn't use sevens with my greater than and less than. Just make my image a little bit easier to read. So yes, you could read this as -7 is greater than x. But remember to graph it in the right direction. This means I always like to put the x on the left. So you can flip it, you flip everything. And so x, now the arrow is still pointing at the x. So if you're going to flip it that way, make sure that the arrow is still pointing the right way. So this really means x, instead of saying -7 is greater than x, we're going to say x is less than -7. All right, so now we're going to graph it. -7 is over here. So what do we put on -7? Open or closed circle? Well, there's no equals, so we put open circle. And then do we go to the left or to the right? Well, x is less than, so to the left. And how far to the left do we go? You're telling me infinity, you're getting it backwards. Because if you're telling me infinity, you're saying it's going to the right. It's going to negative infinity. There's a big difference in going to the left and going to the right. And that's the other thing that people often miss on the interval notation when we get into domain and range is interval notation always has to have the less number on the left, the greater number on the right. So on a number line, you're always going from left to right. When we do to range, we're going vertical. It gets a little bit more complicated, but we'll talk about that I think halfway through unit 2. Okay. So how far to the interval notation is how far on the left are we? Well, we're going to negative infinity. So do we use parentheses or brackets? It doesn't matter whether there's an equal here or not. We have infinity. Always use parentheses with positive and negative infinity. And then comma. How far to the right we go? Well, -7. And then we use open circle, so we're using parentheses because there is no equal. All right, so this is one place, so in MyMathLab, if they want you to, that's the graph. This is the interval notation. If they say inequality notation, that's the whole thing. And this is important because when we're solving equations, we get just like x equals a number. And so we don't have to put the x equals, we just put the number. And you can get away with that because we know it's an equals. But it's an inequality, we have to know that you got the inequality right. That means you have to put the whole thing in here. You can't just put -7. Because are you going to the left of -7 or are you going to the right of -7? So that you have to put that entire part there. All right, sorry about that. I had to pause and get some other stuff done. All right, so where was I? Yeah. So I think I was talking about the inequality notation. So in MyMathLab, if they want the solution, if they say inequality notation, put the entire inequality in there, not just a number. Otherwise, you're going to get counted wrong, because then that's acting like an equation. This is definitely not. It's an inequality, not an equation. So we have to respect the medium that we're in. Right? Okay, so that is so when we get to the answers, this is what we're going to have to do with the answers, right? We're going to have to graph it. We're going to do the interval notation and the inequality notation. All right, so that's where a lot of the mistakes are typically made with this is in the end part and not so much the solving. So when we're looking at the solving, So like I said, in general, solving inequalities works the same as solving equations. There's two differences. One, because we talked about the answers now. The other difference is if you multiply or divide both sides by a negative number, then you're going to have to reverse the inequality or flip the inequality. And so this is typically like, this happens at the very last step, when you're trying to isolate x, if you have like negative 4x, you're going to divide by negative 4. So that's going to be their last step. So the reason we have to flip that inequality, make greater than is less than or vice versa, is what do we know about 2 and 3? If I was to put the proper inequality in there, well, we know 2 is less than 3, right? But let's say we divide both of these by negative. If you divide or multiply something by negative, it just changes the signs. So now we have negative 2 and negative 3. So now what would be the appropriate inequality? Well, negative 2 is to the right of negative 3. And negative 2 is greater than negative 3. If you're overdrawn your bank account, negative 2 is better than negative 3 because you're not quite as in debt, right? So negative 2 is greater than negative 3. So at that very last step, if we're multiplying or dividing both sides, and it has to be both sides, not just like sometimes you have like a distribution to do in the solving process. If you're distributing negative, don't flip it. But at the very end, if you're dividing by negative, flip that inequality. That gets missed quite a bit because that's the new part of solving the inequalities, and you're so used to solving equations that you don't have to think about it. But just be aware of that. That's an extra step. That gets missed a lot. All right. Let's jump into some problems. See how it goes. All right, solve the inequality, graph and express your answer using interval notation. So we're solving x plus 7 is less than 5. Well, before solving it, we want to, these are not quadratic equations. We could have quadratic inequalities if we wanted to. Again, that's one of those things that's definitely a higher level skill that we're not going to get to this semester. But just know that we could have quadratic equations in here as well, but we're sticking with linear. Okay, so we're just isolating the variable. So you're just subtracting 7 from both sides. You get x is less than negative 2. And as soon as you get your x isolated, you're done. So that would be the inequality notation. So that's the first part of your answer. So that would be part A. Part B would be to graph it. Okay, so for negative 2, we're doing open circle where there's no equals. And which direction are we going? Well, x is less than. We're going to the left. Okay. And like I said, on MyMathLab, which I'll show you, that would be multiple choice to find. Then part C, we want the interval notation. The interval notation is how far left, how far right. It's the endpoints. So how far left does this go? It goes, and please don't tell me infinity. It's negative infinity. Always use parentheses with positive negative infinity. And then to the right, we go to negative 2. Then is that parentheses or brackets? Open circle, no equals, and it's parentheses. Now, sometimes they want just the inequality notation. Sometimes they want that and the graph. Sometimes they want just the interval notation. So which part of, they don't always want all 3 parts, but you need to find all 3 parts most of the time. But like if they would just want interval notation, you got to do all this anyway. They just want that part. So make sure you're reading the instructions on these problems. All right. So let's do number 8. So we have negative 5x plus 1 is greater than or equal to negative 6x plus 8. Right. Since we have variables on both sides, you need to make a choice. Now, here's where it kind of depends on what works best for you. Since I'm comfortable with reading the inequalities, I like to move the variable to the side so that I have a positive number in front of my x. So that way I don't have to worry about dividing by negative at the end. If you find yourself a little iffy on the like which way to graph, then my recommendation is always get your x to the left, because if x is on the left, you're going to read it in the right direction. Yeah. It turns out in this problem, both of those are solved, satisfied by getting x to the left, because if you are going to take it to the right, you'd be adding 5x to 0 on this side, and then negative 6 plus 5 would be -1, so it would have a negative coefficient. However, if we take our x's to the left, we're going to be adding 6x to both sides. And then -5 plus 6 is going to give us a positive 1x. So not only is it on the left, but it's a positive. So in this case, like when in doubt, when you're solving inequalities, my recommendation is get the variable to the left, and then just be aware that you may have to flip this inequality if you divide both sides by a negative. We'll do an example like that so I can show you for sure. Now to save time, I'm going to go ahead and subtract 1 on both sides. Since I'm getting the variable to the left, I'll move the constant to the right. Now we get 1x is greater than or equal to 7. Well, we're actually done. So x is greater than or equal to 7. That's our inequality notation. When we graph it, so what do we put on 7? It's a bracket, so put closed circle. X is greater than, go on to the right. And then for the inequality notation, the left is 7. It's a closed circle because the equal, so we use in brackets. To the right, it goes to positive infinity, and then always use parentheses with infinities. Okay. Like I said, the solving, this is like the entry level. Like if there was an equals there, that would be like entry level into our 1.1 homework. So that's why I say the solving is a bit more straightforward. You might have a distribution to do. And just handle that, do your distribution and then probably have a problem like this. Now I want to back up and do number 7, but I want to do it, get the variable on the right, because that'll show you a couple different things. So if we're going to get the variable to the right side, we're going to subtract 8x from both sides. And at the same time, I'm going to move since I'm getting the variable to the right, I'm going to get the 5 to the left. So now we have -7 is less than or equal to 7 minus 8 would be -1x. Okay, so we're not done yet because we don't have positive x. So we need to do something at -1. Well, that's -1 times x. So we're just going to divide both sides by -1. Okay, so -7 divided by positive, -7 divided by -1 is +7. Now here's where you have to be careful. We divided both sides by negative, so that we have to flip or reverse that inequality. So the less than now becomes a greater than or equal to. So if you're dividing both sides by negative in this last step, make sure to flip that sign. Okay, so 7 is less than or equal or greater than or equal to x. So what does that graph look like? Let's see, there's an equals, so we're using closed circle on 7. I don't know why so many of my examples have 7s with these inequalities, so I apologize if I'm not making them clear enough. Okay, so now do we go to the left or to the right? Some people look at this and say, well, the arrow's pointing to the right, so we need to go to the right. Don't go by the direction the arrow's pointing. Go by what is x. And so read this from x's perspective. The arrow is pointing at x, that x is less than. And so we're not reading this as 7 is greater than or equal to x. You need to read this as x is less than or equal to 7. So since x is less than, we got to go to the left. Basically, if x is on the right, it's backwards what you might initially think. That's why I recommend, in general, with these inequalities, linear inequalities, if you get your x on the left, then it's more straightforward to read it to get your direction. And then for the interval notation, We're going forever to the left. That's negative infinity with parentheses. Goes to positive, it goes to 7, and equals, so we use a bracket. All right. Like I said, the solving process is the same as solving any equation, same as solving equations, unless at the very end you divide by negative, then you do need to flip, less than become greater than become less than. Now, I'm not going to do number 9, but we'll talk about how to get started. And so, we've done equations with fractions in 1.1. And so how did, if this was an equals, how would you deal with those fractions? Well, hopefully you would find the LCD and clear the denominator. So what I would do first is, 18 is LCD because 3 goes into 18. So I'd multiply every one of those by 18. Once you do that, it should simplify down to where you have an equation that's back to whole numbers. Once you do that, then it's just what we do. All right. So that is linear inequalities with a single inequality. So let's look at compound inequalities. The compound inequalities have 2 inequalities in them. Right, so if we're trying to solve negative 16 is less than 4x is less than or equal to 24, we're still trying to figure out what x is. So what is our goal? How do we solve for x? Well, if we were doing a regular equation or inequality, our goal would be to isolate x on one side or the other, but we've got 3 sides. We don't have 2 sides now, we have 3 sides. And so our goal of these compound inequalities is to isolate x in the middle, whatever your variable is. It could be y, it could be r, whatever. And I will say that for some reason, I see a lot of examples written where they split this out, this compound, and they'll say, solve negative 16 is less than 4x. And then they'll say solve 4x is less than or equal to 24, and then put the answers together. Well, putting the answers together, you really have to know we're talking about and or, and that takes it to a kind of a higher level of problem. So I can kind of theoretically see why they're doing it, but for us, we're not doing and or inequalities. So by splitting it up, that is making way more work than you need to do for what we need with this. So that's why I'm saying just isolate x in the middle. That is our goal. Don't split it up into 2 inequalities. Keep it up as one big one and go from there. Excuse me. So when I say that, if you're going to isolate, if you're going to get x by itself in the middle, what would you do with 4x? Well, divide by 4, right? Now, if you divide the middle by 4, what do you have to do with the rest of the equation? Well, if this was just a single inequality or equal sign, then what you do to one side, you do the other. And now we have 3 sides. So whatever you do to the middle, do to all 3 sides. It has to be all 3 sides. So if we're dividing the middle by 4, divide the left by 4, divide the right by 4. So negative 16 divided by 4 is negative 4. It's less than x is less than or equal to 6. So we've isolated x in the middle. So we're good. And then if we're going to graph this, let's put 0 there as a placeholder. Got negative 4 on one side, 6 on the other. And 0 is not always going to be in the middle. They could both be positive, both be negative. Just like I said, I just like 0 in there. So what do we put on negative 4? Open circle or closed circle? Well, there's no equals, so open circle on negative 4. There is an equal on 6, so it's closed circle. This is what we call half closed or half open. And then it's everything in between. So interval notation is how far left. So how far left is negative 4. There's no equals, so we put parentheses. So negative parentheses negative 4, comma 6. There's no equals, so we put the bracket on the 6. That's compound inequality. You're just getting x, your variable, in the middle by itself. Now I'm going to do 13 because it has some fraction stuff in it that we need to talk about. It's a little bit higher version of 12. So, but let's just talk about how we start 12. So if we're trying to solve this, what would you do to isolate x in the middle? Well, the first thing is you would subtract 5. So would subtract 5 from the left, the middle, and the right. Once you get those numbers, well, we have 4x again, so we just divide all three sides by 4. So number 12 is number 11 with the one extra step, but we had to subtract 5 from the left, the right, and the middle. So there we go. That's what. Okay. So let's look at 13. So most of the time with these, we're dealing with whole number answers. So let me show you one with a fraction. So 13 is we have 40 is less than or equal to 20x minus 30. 30, not 36, is less than 60. All right, so we're trying to solve this. We're trying to get x in the middle by itself. So first thing we're going to do is add 30, all three sides. Left, right, and middle. $70 is less than or equal to 20x. It's less than 90. Now to get x in the middle, divide everything, all three sides, by 20. Now these, I'm going to simplify those just because they both end in zeros. I know I can divide them by 10. 7/2 is less than, the x is less than 9. Don't go to decimals. MyMathLab is fine with fractions. The only reason you'd go to decimals if it mentions decimals. So 7/2. And don't go to mixed numbers because it's simplified because there's nothing to divide 7 and 2. There's nothing to divide 9 and 2. So those are simplified fractions. Okay. So that's just like we did before, except we just happen to get a fraction as an answer instead of a whole number. Okay. Now the question is, how do we graph fraction, improper fractions? So if it's proper fractions, we know that's between 0 and 1, or 0 and -1 if it's a negative fraction. But what about 7/2 and 9/2? Well, this is where decimals can come in handy, or mixed numbers. That's kind of what we need to see how to graph improper fractions. So 7/2 is 3.5, or it is 3 1/2. 9/2 is 4.5, or 4 1/2. So that's where, when I want to graph fractions on a number line, going to decimals or mixed numbers is the way you want to do it. So we need 3 1/2 for one of them, 4 1/2 on the other. Okay, so 3 1/2 would be, now on the 3 1/2, which is going to be halfway between 3 and 4, it is, excuse me, equal, so we're going to use closed circle. There would be our 7/2. The 9/2, which is 4 1/2, so it's halfway between 4 and 5, is no equals, so it's open circle. And then it's everything in between. So that's how you graph fractions on the number line, is convert them to decimals or mixed numbers. And now for the interval notation, how far left do we go? Use whatever number that you got up here. Don't use your decimals or your mixed numbers that you use to graph it. Use the numbers that you had in your inequality. So on the left, it's 7/2. The equal, so it's a bracket. On the right, it's 9/2 with no equal, so it's a parenthesis. So that is compound inequalities. So we're trying to, x is, and the problems we're going to give you, x is always going to be in the middle. Your variable is always going to be in the middle. So you isolate the middle by doing your abstract first. Here, divide last. Theoretically, we could have a negative at here, and then that would flip those. But really what that does is it just kind of writes this backwards. If you graph your numbers correctly on the number line, you get the same answer. I don't think we do any of that in the homework, but it doesn't change the process. If you divide by negative, you are supposed to flip the inequalities. Basically what that would have done was, basically, like if it had been a negative 20, what that would have done is that would have flipped us over, that would have made those numbers negative when divided by the negative, but it still would have been in between, negative 9/2 and negative 7/2. All right. Except how comfortable students are with this section, I think really kind of depends on how much you remember about the graphing and this stuff. The solving is the quicker part of this compared to, like I said, especially compared to what you had to solve in 1.1. And this is much more straightforward. So get into MyMathLab. If there's anything I missed. Oh, and what I was talking about, so since we're not doing 1.6 this semester, this is the last official homework. And so we're gonna have skill check quiz, and then we're gonna be talking about the reviews, and then it's gonna be the test. So expect more information on that coming up soon, but not in this video. All right, so there are 14 problems here. So I didn't share it. Go back. When I changed screens, it didn't share. All right, so this is what I was talking about. The graphing part is multiple choice. So if x is greater than or equal to -6, when it's multiple choice, a lot of times you don't have to maybe do like the full thought process, but basically you have to know what direction are you going, left or right, and is it open circle or closed circle. And now here, they're not always consistent on this. Notice that in the graph, they're using parentheses and brackets on some of these. There's probably other ways use open circle and closed circle. Remember, open circle and parentheses are equivalent, and then closed circle and brackets are equivalent. So when I see this, x is greater than -6. So since x is greater than, we're going to the right. So it can't be B or C because those are going to the left. And so A and D start at -6, go to the right. And so do we want parentheses or brackets? Well, there's an equals, so we use the brackets. Or depending on the problem, we could have a closed circle. I think I've taken some of these problems from a couple different books to give you enough variety. And so some authors, even on the graphs, use parentheses and brackets, which is kind of what I'm used to. But more commonly, they use open circle, closed circle. So you have to be flexible to know, open circles, parentheses, or closed circles and brackets. So this one would be D because going to the right, and we need the bracket. Yeah. So here's one, they give you the graph and they want the interval notation. So what is the resulting interval? And so remember, interval notation is how far left, how far right. So we start on +3 on the left, we go to +9 on the right. How do we enter this answer? I was just checking. Some of these problems, it's not this one. What I was looking for was like, let me close that up. So when I click on the answer box, I don't want, it's giving me more. I just want the original. I'm playing around with the answer box real quick. So it was, when I first clicked on it, I guess now that I clicked more, it's not going to let me go back to the original button palette. Let me go to a different question. So when I click on the answer box, it's going to give me this whole time note. So you have like the parentheses on either side as an ordered pair, that would work. I've seen it in the past where they give you like all the options of like parentheses, a box with parentheses on both sides, a box with brackets on both sides, or one or the other. But just know you use your keyboard to get the parentheses and brackets. Sorry, I'm stumbling on that because I was looking for something else that didn't show up. So how about this one? We'll back up and do number 2. So on the left, it's 3. There's a bracket on 3. That's the nice thing about putting the brackets and parentheses on the graph. You don't have to worry about open circle and closed circle because we don't have those interval notation. So your bracket is right above the inner. And don't do, if you do shift in that, you get the curly brackets. Don't use the curly brackets. It's either brackets or parentheses. So bracket 3. Don't forget your comma. And then how do you do infinity? Well, infinity, you have to click on the answer box. That'll be one of your button choices. So somewhere, like if there was just one row, infinity should be on that top row. Since I've clicked on it now, it's giving me all of them. Just hunt for infinity. If you're doing, and be careful with your infinities. If you're using negative infinity is always going to be on the left. If you're using positive infinity is always on the right. So if you get these backwards, you will get counted wrong. And then we always use parentheses with infinities. So there we go. Oh, okay. So now it also expressed the graph as an inequality. So basically what they've done is we kind of got the answer, now we're kind of working backwards. So how we do this as inequality. So what that means is they want to, is x greater than or less than something, and is it equal to or not equal to? So start with x. Now we're going to the right, so that tells us x is greater than. So if you go through your button palettes, and again, if you don't have the multiple rows, this should be in the top row. So do we want greater than and or equal to? Well, because of the bracket, we use equal to. And what is it greater than or equal to? It's equal to 3. All right. Like I stumbled through that a little bit because I was looking for something. Let me back up and do number 2, same way. Okay. All right. So use interval notation to describe the graph. So that's where we're starting. So we need how far left, how far right. Okay. So we have a bracket. So bracket 3, comma, and then on the right we have 9 with the bracket. I almost feel like it's cheating that they give you the brackets and parentheses on here. If they use an open circle and closed circle, you'd have to translate that, but they're giving it to you right there on the graph. Okay, so that's how far left, how far right we go. Now use the inequality describing the graph. Now on this, since we're doing the inequality notation, we need a greater than or less than the answer. Are we going to have one inequality or are we going to have 2? If you have 2 numbers on your graph, that's a compound inequality, so you need 2 inequalities. All right, so like on number 3, yes, I want to come back to it. On number 3, if it goes to positive infinity or negative infinity, that tells you it's a single inequality. Okay. If you are in between 2 numbers, you have a compound inequality. And so just read this basically from left to right. So we have 3. Now, do we want, and so with compound inequalities, you use less than. So are we using less than or equal to? Well, there's a bracket, so we need less than or equal to. So then x is in the middle, and then we're going to 9, and so x is less than or equal to 9 because of the bracket. Does that make sense? Like I said, we're kind of starting at the middle of the answer and kind of working backwards, both or out from the answer. So normally what we're doing is you're going to solve something, you're going to get this answer, and then once you have this answer, then you're going to graph it. So we're kind of working backwards from the graph to like where did we get that from? Does that make sense? Hopefully. Okay. But like I said, if you have 2 numbers, make sure that you're using 2 inequalities because it's a compound inequality. And both of them are going to be either less than or equal to, depending on whether or not there's parentheses or brackets. All right, so let's do another one. So the graph represents the interval. So type your answers in it. So again, make sure you're reading the instructions. So the interval notation, so how far left, how far right. So on the left, we've got -3 with a bracket. So bracket, -3, comma. On the right, we have 6 with a parentheses. So 6 parentheses. So you see why I like having the graph to do the interval? To me, it just makes it so much more straightforward because it's right there. And you just want the left and you want the right. Now type an inequality using x as a variable. And again, we have two numbers, so we need two inequalities. So x is going to be between these. So just start on the left. So -3. Now the compound inequalities, it's always less thans. Is it less than or equal to? Bracket, so it's less than or equal to. So x is in the middle. And then for the 6, there's parentheses, so there's no equals. So we just use less than. Okay, so these could both be less than or equal to. They could both be less than. It could be one of each. It depends on the graph. All right. Yeah, so this one is interval notation and then illustrate it. So let's start here. So once the interval notation, this is where if I was doing this on paper, I would definitely graph it first. MyMathLab doesn't let us do that because it makes us do the interval notation first. So the first thing I would do is going on the graph, on the number line. 1 and 9. And then what are you putting on 1? Well, you're putting an open circle, closed circle or bracket. So both of these are closed circles or brackets. It's in between. So it's a compound inequality that it's telling you the left and the right. So the left is 1. There is a bracket there. So 1, comma, and then we go to 9. And then we want to bracket because of the equals. So compound inequalities are nice on the interval notation because you already have the left side and you already have the right side. You don't have to worry about positive, negative, infinity. It's all right there for you. Right, now we graph it. Like I said, if it was me writing this problem, I would have flip-flopped these. And so since it's multiple choice, when I'm looking at this, like D, I would eliminate immediately because it goes forever. It doesn't stop at 9. So it can't be D. Now the rest of them are all 1 to 9. So then it really comes down to parentheses and brackets. Well, we got 2 equals, so we need 2 brackets, which is what we use there. So it'd have to be A. All right, so you got a couple of those, and then you get into the actual solving. Okay, oh, I knew there was another reason I was doing the MyMathLab. So the set builder notation is something that if you haven't done logic, you may have not seen this before. This kind of popped up in random places. The set builder notation, notice there is a bracket and then X and then a vertical bar and basically your answer box and then a bracket again, like a curly bracket. So anytime you have set builder notation, you're always going to see this notation. So the way this reads, anytime you have curly brackets in math, that's the set. So it's the set X. That vertical bar means such that. So this is the set of X such that, and then in that answer, that's when you solve this, we're going to subtract 5 from both sides. We're going to get X is less than 2. That's what they're looking for. Oh, what comma or less than. You can also use your keyboard to get your less thans. All right. So if the set builder notation is throwing you, actually you can kind of ignore that and just put your inequality, solve it, put that answer in the answer box. And don't put just 2, because we need to know, is it X less than 2, X greater than 2, X less than or equal to 2, X greater than or equal to 2. So if you just put 2, that's going to get counted wrong. Because there is no inequality in there. That X is not part of the solution. That X right there is part of the set builder notation. You're going to see that in every single problem that says set builder notation. You need the whole thing. X is less than 2. And then interval notation. And then they want to graph it. Again, I kind of wish they would have you graph it second and then do interval notation last. But, we've talked about this. So if you graph it, we're going to, parentheses on 2. And then x is less than, so we're going to the left, forever to negative infinity. So if you want negative infinity, you do the negative, which is right next to the 0. That right there is a subtract sign, so don't use that. Yeah, you got to use the negative sign on your keyboard. I'm pretty sure it'll, let me test that. Let's see if it gives us an error. Depends on who wrote the problem. And then it goes to 2, and then we want. So whoever coded this actually, like if you did this on a calculator and you put the minus button on your calculator, you get it counted, you get an error because it's subtracting. It actually accepts the minus on that. So okay, so x is less than 2. Well, x is less than, so we're going to the left. So it has to be either C or D. There's no equals, so it can't be D. So it has to be C. And in my brain, I would do this on my paper. And then once I have this, then I go back to the interval notation, because we're going to negative phi on the left, positive 2 on the right. So, here's a typical, linear equation. Now, what do you have to be careful of on this particular problem? Well, after you subtract 2 from both sides, you're going to divide by -8. And what do you have to do when you divide both sides by negative? You have to flip that inequality. So in your final answer, it should be x is greater than, not x is less than. Other than that, straightforward problem. Okay, and then after some linear inequalities, then you have a couple compound inequalities. Be careful. Sometimes when there's a 0 on one side, people tend to lose it. Like 0 doesn't matter. 0 matters. So when you add 6 to the middle, you need to add 6 to the left and 6 to the right. So you're gonna have a 6 is less than or equal to 3x is less than or equal to 12. So don't lose that just because there's a 0 there. All right. So I think that they might have. Looks like they took not even. I was looking for a fraction of this answer. Notice that they say use integers or fractions, and so don't go to decimals. Don't go to mixed numbers. If it is a fraction, keep it a proper and improper fraction. All right, that is inequalities. Like I said, by the time you get here, if you've done your 1.1 homework and you feel comfortable solving those messy any equations in 1.1, this should feel like a little bit of relaxation. It's just, as always in an algebra class, there's always something a little bit extra every time we add a new topic. So don't forget to flip the inequality if you're dividing by negative at the end. And on the interval notation, make sure it's always left first and right second. Okay, that's all I have. So have fun with this. If you have, as always, have any questions, email me. See, I guess the next thing on the list would be a review for the test. Have a good day.